Hi guys, welcome to this page of the notes, and what we're going to do now is we're going to take what we just learned about vertical and our 3 rules for finding horizontal asymptotes and apply it to graphing a rational expression. I'm really excited to go through this with you. I cannot wait, but I need to make a quick note first. Alright, for those of you who are taking this class with me, when it comes to your graphing calculators, yes, your graphing calculator will graph this function. However, I need you to be able to do the math and sketch these on your own. So, if you want to Google it or sort of refer to the user manual to figure out how to graph these functions on your graphing calculator and then use that as a way to check your answer, okay, fine, you're welcome to do that. However, if you're taking this class with me, these are going to be free response questions on your test, meaning on the test, it'll look exactly like this. I'll give you a rational function. I'll give you a coordinate plane to graph it on, and since I've given you the coordinate plane, that means the function must fit on the coordinate plane I've given you. And then, again, those of you who are taking this class with me, you will recognize this. You've seen it before. Down at the bottom, I will have these boxes where I ask you for the information I am looking for. Remember, these are free response questions. I am grading your work, not necessarily your final answer, right? And partial credit is available. You could do absolutely everything right, forget a sign somewhere, wind up with a slightly wrong answer, and you're not going to miss all of the points. You only miss a few of the points because you did most of the work right. But what this means is, if you're taking this class with me, you've got to do all of this work anyway. And your graphing calculator will not give you this information. So, since you have to be able to do the work anyway, and if all you do, right, is put this in your graphing calculator, sketch the graph on here, and leave all of these blank, I'm not going to give you any credit anyhow. So, taking this class with me, put that graphing calculator away, follow along with me because you need to know how to do this math. Now, if you're taking this class somewhere else with another teacher, I love graphing calculators. They're fantastic. But you should be able to do this stuff on your own. Now, if you have a teacher who wants you to be able to use a graphing calculator, fantastic. They're wonderful tools. I love them. And you'll just Google it or refer to your user manual for graphing rational expressions, but it doesn't hurt you to know how to do all of this math as well. So let's go ahead and jump right into these and see how these problems work. I jumped down here to the table, and guys, really you could kind of use this as a roadmap when doing these problems. I kind of walk you through what you need to do to get the graph. Since the first box asks you for the X-Intercepts, that's probably where you should start, right? The first piece of information to find. Well, if you recall, we talked about X-Intercepts in the previous section. And in the previous section, we said you will cross the x-axis when y is equal to 0. So, let's do that. My function is f of x is equal to x cubed over x minus 1. Okay, well, f of x is y. And I need to set this guy equal to 0 to find the x-intercept. So 0 is equal to x cubed over x minus 1. Multiply the x minus 1 to the other side. 0 times x minus 1 is equal to x cubed. Well, 0 times anything is just 0, and so I wind up with x cubed is equal to 0. Well, now what I need to do, right, is get that x by itself. Since the x is cubed, take a cubed root of both sides. X is equal to the cubed root of 0, and that's an easy one. The cubed root of 0 is, of course, 0. Here's what that tells me, right? This gives me a point. I now know that when y is 0, x is also 0. X is also 0. And so right away I know that I'm going to have a point at 0, 0. And since you did all this work up here, I'll just put right down here in the box that I have an x-intercept at 0, 0, I'm sorry, at x equals 0. And my point is 0, 0. So I'll plot that point when we go about graphing the function. Okay, well, the next box, I ask you to find all vertical asymptotes. Well, that's easy. We just practice doing it. You take the denominator and set it equal to 0. Our denominator in the function above is x minus 1. All right, let's do that. So x minus 1 is equal to 0, which means x is equal to 1. And so I now know that I have a vertical asymptote at x equals 1. I will have a vertical line, a vertical asymptote at x equals 1. All right, the next piece of information I need you to find for me is, you guessed it, horizontal asymptotes. That means I need to know the degree of the top and the degree of the bottom. Well, if you take a look at the function above, it was x cubed over x minus 1. That means the degree of the polynomial in the top is 3. It's an x cubed, so the degree is 3. b of x, the polynomial in the bottom, it's an x minus 1. The x is to the first power, so that's the degree. And based on this information, the degree of the top is 3, the degree of the bottom is 1. That means that a of x, the degree of the top, is greater than b of x, the degree of the bottom. Now, which rule is that? Well, the degree of the top greater than the degree of the... That's rule number 1. Rule number 1, which means that I have no horizontal asymptote. What that does mean is I have an oblique asymptote, a slanted asymptote, and we'll work on finding those guys later. Now, if you're taking this class with me, I will not give you a problem like this to graph on the test because this one does wind up looking a little, yes, it's a rational function, but it doesn't quite look like our other rational, like the reciprocal parent function. It's a little more distorted than that because of the x cubed in the top. So anyway, the stuff we can plot, I know I have a vertical asymptote right here at x equals 1. I know that I have a point, right, at 0, 0. I cross it 0, 0 thanks to the information I found in the boxes below, and I have no horizontal asymptote. It's going to be a slanted asymptote. And again, if you're taking this class with me, I won't actually give you one like this to graph. Based on the pieces we have, we would be able to find that slanted asymptote and graph the function. But just for now, this one would look like this. If you were to plug it into your graphing calculator, it would take off like this, like that, and then come from the opposite direction, come down about to there, and then head off in that direction. Again, you have no way of knowing that the shape of it's going to be like that without further work or using your graphing calculator to verify. But again, if you're taking this class with me, you'll see here in a little bit the problems more like the ones I'll actually give you on a test or a quiz. This was just to help us practice finding x-intercepts, vertical asymptotes, and horizontal asymptotes. Head on over to the next page of the notes. We'll try another one. I'll meet you guys there.